What's up, guys? It's me, Sir Ernest, and today we're going to solve another example on calculating the center of mass. In this case, we're going to look at center of mass of a solid hemisphere. So this example is an example of a three-dimensional problem. So this means that the volume element that we're going to look at would be dV. Okay, but first let's illustrate this problem. So we say we have a hemisphere. That means this is half of a sphere. And let's say that the half of the sphere, the base of the half of the sphere, lies along the xy axis. And then the hemisphere is above the xy axis. And then also, let's assume that this is a uniform solid hemisphere. So that means the mass density is a constant. So this is your base. And then let's say this is your half. Okay, and then say this is your y-axis, this is your x-axis, and this will be your z-axis. The volume element that we're going to look at would be the volume element of a disk, wherein the thickness of the disk is dz. Okay, so this is your disk. The radius of the base, so let's call the radius of the sphere that this hemisphere belongs to, let's say, is radius A. So let's try to draw that in a more convenient way. So that means, so let's say that the horizontal axis will represent our x and y components, x and y axis. And then the vertical components will be the z axis. Okay, so let's do that. Okay, so let me just erase it, this one, this part. So this will be your x. Okay, so let's draw the xy plane in two dimensions. So they say this will be your xy plane. So this will be your z. So this will be your xy plane. And then your hemisphere would look something like this one. Okay, so let's make a circle. And then let's delete the bottom. Okay, and then let's draw the disk. So the disk should look something like this. Okay, so this is your disk. And then the thickness of the disk is dz. So the distance between the xy plane to the disk is called as the z. The radius would be a. The radius of this disk is called that r. And then if we're going to zoom here, and then so this side will make a arc along this segment of the sphere. Let's draw a segment here, and this segment. This is the theta, and then this segment is theta. This length and this length are both a. Okay, so let's do the calculations now. The radius of the disk element, this would be r, and that is related to z and a. So remember, this is a, this is r, and this is z. So by Pythagorean theorem, this should be equal to a squared minus z squared to the 1/2. And then the area of the disk element is pi r squared. So therefore, the volume element of this disk equal to the area of the disk times the thickness of the disk. So this becomes pi r squared dz, or pi times a squared minus z squared dz. So you will notice here that your volume element will now be in terms of z. So that when we integrate later, this becomes a one component integration. So also, as you will notice that by symmetry, the y and the x component of the center of mass will be equal to 0. So that means we expect that the center of mass will be along the z-axis. Using this definition, we can now calculate the z component. So this is now equal to integral of rho z dv divided by integral of rho dv is equal to integral of rho z, then pi times a squared minus z squared dz, and the integration will happen from 0 to a because this distance is a. So this is from 0 to a, and then divided by integral of rho times dv, which is pi a squared minus z squared dz, integrated from 0 to a again. So if you're going to do the integration, you can actually cancel rho because remember that rho is a constant. By doing this, we now have, oh, by the way, no, we can also cancel pi because pi is also a constant. So now what we're now left with is integral from 0 to a of a squared z minus z cubed dz divided by integral of a squared minus z squared dz, which is equal to this result. So this is a squared z squared over 2 minus z to the fourth over 4 integrated from 0 to a divided by a squared z minus z cubed over 3 from 0 to a. And if we're going to evaluate this, we will now left with the value of ZCM to be 3 over 8A. This is equal to exactly 0.375A. So if we're going to locate that here, it should be somewhere here. So this will be your center of mass. So for this view, it will be somewhere here. This will be the center of mass. So that's it. So the center of mass of a solid hemisphere with uniform density, the x and y component will be 0, and the z component will be 3/8 a, where a is the radius of your hemisphere. So that's it. Thank you guys for watching. I hope you learned something today about calculating center of mass. The next video, we're going to calculate more examples about this topic. For now, thank you guys, and I will see you in the next video. Bye bye.